Start. Hello, I'm Anusha. Our seminar topic is NS3, which is basically a network simulator. I'll give introduction about NS3. Coming to the introduction to NS3, basically first we need to know what is NS or NS2. NS is a discrete event network simulator for internet systems, protocol design, multiple levels of abstraction, and basically NS is written in multiple languages like C++, OTCL and so on. NS as a companion network animator called NAM, and hence it has been called as NS-NAM project. Coming to the features of NS3, NS3 is an open source licensing and development model. Python scripts or C++ programs, alignment with real systems, alignment with input-output standard, test-bed integration is a priority here, basically in NS3, modular, documented code. Let's know the relationship with respect to NS2. So NS3 is not an extension of NS2. It does not have an OTCL API. C++ is wrapped by Python. Guts of simulator are completely replaced here in NS3. New visualizers are in work. What are the differences from other network simulators? So NS3 command line Unix orientation, simulations and models written directly in C++ and Python compared to other simulators. Coming to the overview, NS3 is written in C++ with bindings are available for Python as well. NS3 is a GNU licensed project. NS3 is mainly supported for Linux, OS, Windows Visual Studio. NS3 is not backward compatible with NS2. What are the special features about NS3? So C++ only simulations, so no need to debug two languages at the same time here in NS3. So NS3 is a library written in C++. Simulation programs are C++ executables, bindings in Python for Python simulation. So these are some special features of NS3. Coming to the architecture of NS3, so first coming to introduction, we need to have an environment setup. So we have to install all the needed tools. Can work in Ubuntu as well Windows. So in Ubuntu we have sudo apt get install build essential G++ Python. Windows we have like Cygwin, Python, Mercurial and so on. So how to run NS3? So we use WAF to build it, like we have like /WAF, /WAF shell, /build, /debug, /example, /ESMA broadcast. So we have a basic model of NS3. So here the components are like node, we have node, application, socket, net device and channel. So basically node, motherboard of a computer with RAM, CPU and input-output interfaces. So application, a packet generator and consumer which can run on the node and talk to this set of network stacks as well. So socket is an interface between an application as well the network. Netted device, so it is a network card which can be plugged in an input-output interface of a node. So what is a channel? Channel is nothing but a physical connector, okay, between the set of the devices, objects, whatever it is, between the net devices.
Hello, this is Suman. Now I am going to explain how to download and install NS3.
NS3 can be installed only on a Ubuntu or Fedora platform. If you are using Windows as your operating system, then you have to install VMware to use NS3. This is the link to download VMware. After downloading VMware, you have to install VM player that you will get here. After installing VMware and VM player, we have to now the Ubuntu will be installed. After installing Ubuntu, we have to open a terminal, clicking applications, accessories and terminal. After opening a terminal, we have to install some prerequisites in order to use NS3. First, you have to type these commands. This will install G++, Mercurial and Flex in your terminal. After doing this, you have to create a directory using mkdir command. Once you are done with that, you have to change the root directory to NS3. After doing that, you have to download NS3 by typing the official link as shown below. Now the NS3 will be downloaded. It will take 2 seconds. It's downloading, 45% is completed. We are almost done with that. The file is successfully downloaded. To unzip the file, you have to type this command now. It will take few seconds. After unzipping the file, you have to type ls command. After doing this, you have to copy that and you have to paste it again. You have to change the directory to copied command. After doing this, you have to type ls again. Now it will be built. Then you can find build.py along with other files. Yeah, here it is. Then to build the examples in NS3, run the below command. Here it goes. This is how it works. It takes few seconds, few minutes. After taking some minutes, build will be completed. After completing build, it will display this message. Build finished successfully. After building, now run the following command to configure it WAF. Press enter. Press ls command. The directory name should be set. This is how it executes. After configuring, it will display this message, finished successfully. Then, to build with WAF, you have to type ./WAF. Press enter. Again it shows the same message, build finished successfully. To test everything alright, you have to type ./test.py. Press enter. Here it goes. Yeah, this is the ending of your installation process. Thank you.
Hello everyone, I am Pratibha and I am going to demonstrate a simple NS3 program. Okay, before moving on to the program, first we need to know some of the key abstractions required for NS3 programs. The first thing is the node. The node is the basic computing device which is used in the program. This abstraction is represented in C++ by the class node. The node class provides method for managing the representation of computing devices in simulation. The second abstraction is the application. The application is nothing but a user program in which the simulation will be run. This abstraction is represented in C++ by the class application. The application class provides methods for managing the representation of our version. And the third thing is the channel. The channel class provides methods for managing communication between the subnetworks, and it is also used for connecting nodes. Channels may also be specialized by developers in the object-oriented programming sense. A channel specialization may model something as simple as wire, which is the wire used for connecting the two nodes. And the fourth abstraction is net device. A net device abstraction covers both software drive and the simulated hardware. A net device is installed in a node in order to enable the node to communicate with other nodes in simulation by the means of channels. Just as in the real computer, a node may be connected to more than one channel or by the means of multiple net devices. Topology helpers. Fifth abstraction is the topology helpers. Since connecting the net devices to the nodes and net devices to the channels and assigning IP addresses are such common tasks in NS3, we provide what we call a topology helpers to make it as easy as possible. Now coming to the program, the basic NS3 program. Our code starts with include statements. Each of the NS3 include file is placed in a directory called NS3, which is under the build directory during build process to help to avoid include files name collisions. And the second statement is a namespace statement. The namespace in NS3 project, it is implemented in a C++ namespace called NS3. This groups all NS3 related declarations in a scope outside the global namespace. And the third thing is what we call it is used for documentation purpose. So this document is called deoxygenation documentation system. This document is present in login page of the debugging group. This document is important to run the program because it gives a license to run the program. And the main code starts with the fourth line. This is simple as all like we use in the C program, the same main statement we use here. And the next two lines is used as logging lines. Okay. The next two lines of the script are used to enable two logging components that are built into Echo Client and Echo Server. Now we will get directly to the business of creating a topology and running a simulation. We use a topology helper object. To make this job as easy as possible. Now we are coming to the topology helpers. The first topology helper is a node container. The next two lines of the code in our script will actually create the NS3 node objects. Then will represent the computers in the simulation. These nodes will represent the computers in the system. The node container topology helper provides a convenient way to create, manage and access any node objects that we create in order to run a simulation. Next comes the point-to-point helper topology helpers. We are constructing a point-to-point link and in a pattern which is familiar to you. So we use a topology helper object to do low-level work. Here Ethernet device and wireless channels are viewed as point-to-point net devices and point-to-point channel devices. The next three lines in the script are: first line indicates a point-to-point helper object on the stack. The next line tells the point-to-point helper object to use a value 5 Mbps as the data rate when it creates a net device object. And similarly to the data rate on the point-to-point net device, you will find a delay attribute associated with the point-to-point channel. The final line tells the point-to-point helper to use a value 2 Mbps as the value of transmission delay for every point-to-point channel in the subsequently creates. And next, coming to the next two lines, we will need to have a list of all net device objects that are created. So we use a net device container to hold them, just as we used a node container to hold the nodes we created. So the next two lines of the code will finish configuring the devices and channels. We now have nodes and devices configured, but we don't have any protocol stacks installed on our nodes. The next two lines of the code will take care of that. The internet stack helper is a topology helper that is to internet stacks what the point-to-point helper is to point-to-point net devices. Next, we need to associate the devices on our nodes with IP address. The next two lines of the code in our example is that which declare an address helper object and tell it that it should begin with allocating IP address from the network 10.1.0 using a mask given here to define an allocatable bytes. So this assigns the IP address to the nodes and where it has to be moved. The next line code performs the actual address assignments. It assigns the address to the devices what we have created. In this script, we use two specializations of the core NS3 class application called UDP Echo Server application and UDP client application. Here we use UDP Echo Server Helper and Echo Client Helper objects to make our work easier. The next line here declares the UDP Echo Server Helper. Echo Server Helper is going to install a UDP server application on the node found at the index number, one of the node container we use to manage our nodes. Install will run a container that holds pointer to all of the application created by the helper. The next two lines of the code will cause the Echo Server application to start at 1 second into the simulation and to stop 10 seconds into the simulation. So this starts and stops the Echo server which we require in the program. The Echo Client application is set up in the method same as the Echo server. For the Echo Client, however, we need to set 5 attributes. The max packets, which means maximum packets attribute, tells the client the maximum number of packets we allow it to send during the simulation. Here we are given 1 packet at 1 second. And the next attribute is the interval attribute, which tells the client how long to wait between the packets. And the wait between the packets here we are given is a 1 second. And the last attribute is the packet size. The packet size attribute tells the client how large its packet payload should be. Here the packet's payload is 1024 bytes. We can send 1024 bytes in a packet at one time. Just as in case of Echo server, we tell the Echo client to start and stop. But here we start the client 1 second after the server is enabled. What we need to do at the point is to actually run the simulation. This is done using a global function simulator run. When all the events are executed, there are no further events to process and the simulator run returns. The simulation is then completed. All that remains is to clean up. You had to do was to call simulator destroy, which destroys and exits the simulation program. Now we will run the program what I discussed earlier. So first you need to go to the directory where the NS3 is stored. So change the directory to NS3. In this NS3 we need to go to NS3 version, whatever the version we have installed earlier. So it's 3.19. So move on to the directory. Once you are in this version directory, so here if we want to run the program, it should be in NS 3.19 directory. Again you need to change the directory to NS 3.19. In this, whatever the program we had written, it's stored in the directory. So before, like I had pasted in p2.cc whatever the program I explained. So it's present in p2.cc. This is the program what I explained. So it's a C++ program, so extension should be .cc, and once you copy paste the code, you need to save it. After saving it, we need to compile the code. Before compiling the code, we need to build the WAP and we need to check whether the WAP is working correctly or not. So we need to type this command in the terminal to configure the WAP and to build our project. So this is the command what we need to execute in the terminal. So execute the command what I showed in the terminal. This command will configure whatever the WAP statement, and it will show at the end whether the WAP is successfully configured or not. So after getting this configure finished successful, then your WAP is ready to execute. So again you need to type a command /WAP to see whether it is enabled or not. So once you get the output like this, and we can build whatever the program we have typed. So this is the this is the sentence what it shows like being finished successful. Now we can run the program. So before running the program, whatever the file we have stored, it's in examples tutorial. So you need to copy to the scratch my first for easy here to run. So type the command in the terminal. Copy examples. So now we had copied into the scratch.myfirst.cc. Once you had copied, again you run the WAP before executing your program. So WAP is running and the build is successfully done. Now we need to run the program whatever I showed earlier. So to run the code, these are the commands. So you need to type /wap run. So this is the command used to run program, and our program is now stored in scratch or my first. So here we need not to give any extension. After typing this command, we just run the code and it starts running and build is finished. This is the output what I showed. So we had two nodes, one acts as client and one acts as server, and whatever the time delay we had given is 2 seconds, so it starts around 2 seconds, and the maximum packet size is 1024 bytes, so it's sending 1024 byte to the port whatever port 9 with the IP address 10.1.2. So in the same way, like here the client sends the byte, and next in 2. So we had given the delay like as 1 second for between the client and server. So the server receives the packet at this time, and the number of bytes received is this from the IP address. This whatever the client IP address we discussed earlier is 10.1.2, so it's stored in here, and the server's port number is 4915. And again the server sends acknowledgement to the client saying that it has received 1024 bytes again to the client's IP address from the port whatever the server's port, and at last the client receives the acknowledgement from port this to port whatever the port of the client. So this is the program's output, and this is how the NS3 program works.
Hi, I'm Prashant, and I'm going to explain you about bus topology. Okay, this is the architecture of the bus topology, and this is the backbone, and these all nodes are connected to this backbone, and here only adjacent nodes can communicate with each other, where N1 can communicate with N2 and N2 can communicate with N1 and N3. And we will see a simple program on bus topology. This is the bus topology program. Here are the header files which are needed to run this program, and here we use a namespace variable, and here is the logging component in which we pass the parameters here, and these command line parameters are used for enabling and disabling this logging component, and also for changing the number of devices created. And then we declare two components, server and client here, and as in the previous program we create two nodes that will connect via the point-to-point link, and here we create CSMA nodes, and here point-to-point helper is instantiated and set the default attributes so that we can create a 5 Mbps transmitter on devices and 2 Mbps delay on channel created. Then we install the devices on the nodes and the channels between them. Okay, first we set up the echo server. Here we create UDP echo server helper and provide the required attributes, value, constructor which is the server port number here, and these two functions will start and stop the server application. The server application will start after 1 second and will automatically stop after 10 seconds. And this attribute will define the maximum number of packets, and here we default mentioned as 1, and this is the interval which define the time between each packet, and this is the packet size as we define at the 1024. It is in MB, and here we will start the client application, and it will start automatically after 2 seconds as the server starts after 1 second, and as server the client also stops after 10 seconds. And here we enable PCAP tracing, the first line of the code to enable PCAP tracing in the point-to-point helper, and the second line enables the PCAP tracing in the CSM helper, and there is an extra parameter. Okay, we will see the output of the program. I will copy paste the commands. This command is to copy the file from one directory to another directory. This is the output, and next is the net animation window.